Very good morning. I am Yamini Kodali along with N. Harshavardhan and my supervisor YV Pawan Kumar sir. Firstly, I would like to thank Conference Organization Committee for giving me this opportunity present over here virtually in ISCST 2025, which was happening in Maldives. And my title over here is Uncovering Key Influences of Smart City Development Using Statistical Correlations and Association Rule Mining Techniques. And in this session, I'm going to cover the topics like introduction, problem statement, proposal solution, literature review, methodology and implementation, result and analysis, conclusion, and important reference. Introduction. Rapid urbanization has intensified the demand of smart cities, which play a crucial role in enhancing the quality of life and advancing sustainability. Aligned with the United Nations Sustainable Development Goal SDGs, global initiatives are driving through the transformation of conventional cities to smart cities to achieve holistic national growth. Smart cities, technologies, and data improve survey delivery and foster resilience and sustainable urban environments. The Smart City Index is a metric here which helps to increase the quality of living by analyzing various aspects that influence the growth of smart cities. Thus, it is very essential to quantify the influence of various key parameters on the Smart City Development Index. Problem statement. Although this information or transformation of conventional cities to smart cities has already begun, it remains a complex process to assess which domain, such as mobility, environment, energy, education, governance, economy, culture, or technology is progressing more rapidly. As a result, identifying the specific parameter that is truly driving the growth of smart cities across the world remains a very challenging one. Proposal solution. To effectively manage the resources for the development of future smart cities, this paper proposes a data driven approach to systematically analyze the relationship between key influences like smart mobility, smart environment, smart government, smart economy, smart people, and smart living. And the target parameter here it is smart city index. This uses a Pearson correlation analysis for computing the correlation coefficients and the a priori algorithm for association rule mining to highlight the direct and indirect influences. A real-time dataset is considered here, Smart City Index Analysis from CATIL for this proposed analysis. And these are the literature that I have considered by adding focused area, methodology, key findings, and relevance. Coming to the methodology, the process has started with data loading and data pre-processing. Initially, the data frames are created, proposed solution. In this proposed solution, we first have the Pearson correlation analysis, which quantifies the relationship between any influencing parameter to the target parameter by computing the Pearson correlation coefficient value. When it comes to association rule mining, the a priori algorithm identifies the hidden relationships by finding the association between all influencing parameters and as well as the target parameter. While calculating these PCC values, the influencing parameters are automatically selected by filtering the numerical values, excluding the target parameters, which is Smart City Index. Direct and indirect influence was performed where level 1 is considered as a direct influence and level 2 and level 3 are considered as indirect influences on a target parameter. These are some results and analysis that I have noticed. And this is the overall correlation network diagram. The range of this PCC is from -1 to +1, where the values from -1 to 0 indicate negative correlation, 0 to 1 indicates positive correlation, and 0 indicates no correlation in between the parameters. Here, the green line shows the positive correlation between the connected parameters, and the red line shows the negative correlation between the connected parameters. In a positive correlation, both parameters like influencer parameter and target parameter tend to increase together, whereas in a negative correlation, an increase in one parameter is typically followed by the decrease in the other, which shows the nonlinearity pattern. Highest positive correlation coefficient shows the strongest relation, whereas the least positive correlation or highest negative correlation shows the weakest correlation. And the thick line indicates a strong influence and the thin line indicates a weak influence. And this is level 1 correlation matrix. This matrix quantifies the strength between any two parameters using Pearson correlation coefficient values. It allows the examination of pairwise relationships among all considered parameters. For example, the PCC value of smart mobility and smart environment is -0.22 which is donating a negative correlation. Here we can observe in this diagram as minus 0.22 in between the smart mobility and smart environment. Similarly, the correlation between smart mobility and smart living is 0.11. Here we can observe here in the diagram as 0.11 in between smart mobility and smart living, which denoting a positive correlation. This correlation matrix serves as a foundational tool to identifying both direct and indirect influences of smart city components. In the case of the indirect influences, the overall Pearson correlation coefficient value is computed as a product of direct PCC values and each pair of parameters. And this is the level 1 direct influences, where each direct influences the smart living exhibits the strongest positive correlation on smart index with a value of 0.77. This implies the improvements in smart living parameter have a significant and as well as the direct positive impact on the overall smart city performance. Similarly, smart mobility exhibits the weakest correlation on the smart city index with the value of 0.32. It is observed there is no influence which existing with negative correlation. Each and every influencer has having at least some positive correlation with the target parameter called smart city index. And this indicates that all influence parameters have at least some direct influence. Here we can observe on the target parameter. Level 2 indirect influences. The strength of each indirect parameter is calculated as the multiplication of two PCC values. For example, the level 2 indirect influences from smart government to smart index through smart living exhibits the strongest positive correlation on the smart index with a value of 0.34. Smart mobility exhibits the weakest correlation on the smart city index through smart environment with a PCC value of 0.11. Cumulative negative PCC value of minus 0.07 from smart environment to smart index obtained as a multiplication of minus 0.22, the PCC from smart environment to smart mobility, and 0.32, which is the PCC value from smart mobility to smart city index. Level 3 indirect influences. It is also observed that the strongest indirect correlation is exhibited by the combination of the parameters smart environment, smart government, and smart living, whereas the target parameter smart index with a correlation value of 0.097. This indicates the weakest positive relationship, which we can observe as 0.097 in the diagram. On the other hand, the weakest direct indirect correlation is found by the combination of smart mobility, smart economy, and smart environment on the target parameter smart index with a correlation coefficient value of 0.06, which is negative, weak negative indirect relationship. Based on these observations, it is also concluded that extending the correlation analysis beyond the level 2, that is involving more than two parameters of indirect influence, is unlikely to yield significant insights. And this is the last one. Coming to a conclusion, this paper implements a systematic correlation analysis to identify the key direct and indirect influences of smart cities, which helps to upgrade the smart cities by satisfying SDG number 3. The parameter smart living has highest direct influence on the target parameter smart city index with a correlation coefficient value of 0.77. The parameter smart government has the highest direct influence on the target parameter smart city index with a cumulative correlation coefficient value of 0.33 via the intermediate parameter like smart living. The parameter smart environment has shown the highest indirect influence on the smart city index with a cumulative correlation coefficient value of 0.097 through the intermediate parameters such as smart government and smart living. These findings offer holistic framework that emphasizes both indirect and direct influences, providing valuable insights for policymakers, urban planners to guide strategic planning and sustainable smart city government. And these are some references that I have considered, very important references that I have taken. And thank you.